Welcome back to another episode of Tech Talk Today, where we dive deep into the fascinating world of technology and data systems. Today, we're exploring a crucial topic that sits at the heart of modern data management, the relationship between databases and event streams. As applications become more complex, understanding how to effectively manage data across various systems is essential. So grab your headphones and let's get started. To kick things off, let's clarify what we mean by events in this context. An event can be anything from a user action, like typing a search query, to a sensor reading or a database write. Each of these actions can be captured and processed, suggesting that the connection between databases and event streams is not just superficial, it's foundational. For instance, a replication log, a record of database write events, plays a vital role here. It's generated by the database leader as it processes transactions, allowing for accurate copies of data across different systems. Now let's talk about state machine replication. This principle states that if every event represents a write to the database and all replicas process these events in the same order, they will all reach the same final state. This synchronization is crucial, especially in heterogeneous data systems where multiple technologies are combined to meet various storage, querying, and processing needs. Think about it. A typical application might use an OLTP database for user requests, a cache for speed, a full-text index for search queries, and a data warehouse for analytics. Each of these systems maintains its own copy of the data, optimized for its unique purpose. However, this leads us to a significant challenge, keeping all these systems in sync. When an item is updated in the database, it must also be updated in the cache, search index, and data warehouse. Traditionally, this synchronization is achieved through ETL processes, which involve taking a full copy of the database, transforming it, and bulk loading it into the data warehouse. But this is a batch process, and it often leads to inconsistencies. Let's illustrate this with a scenario. Imagine two clients simultaneously trying to update an item in the database. Client 1 wants to set the value to A, while Client 2 wants to set it to B. Due to timing issues, the database might record the writes in one order, while the search index records them in the opposite order. As a result, the database and the search index end up with different values, leading to permanent inconsistency. This situation highlights the need for robust concurrency detection mechanisms, like version vectors, to avoid such conflicts. Now, we also have to consider the atomic commit problem, which arises when we want to ensure that changes to multiple systems either all succeed or all fail. This problem can be quite complex and expensive to solve, especially when you have multiple leaders across different systems, like a database and a search index. Traditionally, replication logs were considered internal details of databases, not something clients interacted with directly. This made it challenging to replicate changes to other systems like search indexes or caches. However, there's been a shift towards a more modern approach known as Change Data Capture, or CDC. This process captures all data changes in a way that allows them to be replicated to other systems in real time. By making changes available as a stream, CDC enables us to keep derived systems, like search indexes, up to date with the latest data. Imagine a scenario where the log of changes from a database is applied to a search index in the same order they were written. If done correctly, this ensures that both systems remain consistent. However, it's important to note that the database doesn't wait for these changes to be applied to consumers before committing them. While this design allows for operational efficiency, it does introduce the potential for replication lag, which can lead to inconsistencies if not managed properly. Now let's talk about log compaction. This technique periodically scans the log for duplicate entries and only retains the most recent update for each key. This means that instead of keeping an ever-growing log of changes, the system can maintain a more manageable size while still ensuring that the latest state of the database is preserved. As databases evolve, more of them are beginning to support change streams as a first-class interface. This means that applications can subscribe to notifications when data changes, allowing for real-time updates across systems. Tools like Kafka Connect are also emerging, which integrate CDC tools with streaming platforms like Kafka, enabling seamless updates to derived systems. Now, let's touch on a related concept, event sourcing. This technique, originating from the domain-driven design community, treats application state as a log of change events. While both CDC and event sourcing involve logging changes, they operate at different levels of abstraction. In CDC, the application updates the database in a mutable way, and the log is extracted from the database. In contrast, event sourcing emphasizes immutability, where the application logic is built around an append-only event log. In summary, the relationship between databases and event streams is critical for maintaining consistency and efficiency across modern applications. By leveraging techniques like change data capture and event sourcing, organizations can build systems that are not only resilient, but also capable of handling the complexities of real-time data management. And that wraps up our exploration of the intricate relationship between databases and event streams. As we've seen, understanding how to manage data across various systems is vital for building robust applications. Whether you're a developer, a data engineer, or just someone interested in technology, grasping these concepts will help you navigate the evolving landscape of data management. Thanks for tuning in to Tech Talk today. We hope you found this episode insightful, and we look forward to diving into more tech topics with you next time.